Okay, so if we draw an angle in standard position, we want to put the initial side on the x-axis. And we talked last time about how if I go in the counterclockwise direction, that is a positive orientation. So I can put the terminal side wherever I want to. And if this is a positive angle, then I need to show the direction of rotation from the initial ray to the terminal ray. Okay, so this would be considered a positive angle. And I can draw the exact same angle, or the same initial side and terminal side. But if I draw my arrow orienting it in a clockwise way, that would be a negative angle. Now we're gonna draw some angles that are in degrees, and those are pretty easy because we're used to the idea of, you know, an entire rotation going from 0 to 360. That, you know, every that the axes, you probably don't know the terminology, but each one of those is 90-degree rotation, right? And those are called the quadrangles. They're the angles that separate each quadrant. Okay, so we're used to doing it in degrees, but we're going to be doing these in radians. So in radians, we need to get an idea of where all the important angles are. And there are certain angles that we use much more than other angles when we're going around what's called the unit circle. A unit circle, which we will get to in our next lesson, is just a circle that has a radius of 1. So if I know what all these interesting angles are, the ones that we're going to be working with all semester, then if I give you an angle in radians, I can go, oh, okay, that's going to go where one of these interesting angles are, or it's greater than this one but less than this one. I get an idea of how to draw my angle in standard position. So we're going to learn these angles now. All right, so I'm going to draw a circle. And I'm going to place my angles on the circle. Now, we start at 0 degrees or 0 radians, and a full rotation is also 2 pi. And we talked about a straight angle last time, or the fact that if I went halfway around the circle, we would get pi. If I cut that in half, so if I'm just looking at the semicircle in the top part of this, it's going from 0 to pi. If I cut that in half, I'm going to get pi over 2 up here. And if I cut that quarter of the circle in half, what am I going to get for that angle? Pi over 4. Okay, so I'm going to take this pizza, basically, and cut it into slices that create fourths for each semicircle. So I'm going to get a total of 8 pieces. And I'm going to do that just by counting around the circle in fourths. Okay? So if I start at 0, then I go pi over 4, then here, that would be 2 pi over 4, which is the same thing as pi over 2, right? And then if I come over here, that would be 3 pi over 4. Then I would go 4 pi over 4, which is the same thing as pi. Then over here, I'm going to get 5 pi over 4. And if I come down here, I'm going to get 6 pi over 4. And we're going to reduce that. What would that really be? 3 pi over 2. So let's label it with the reduced fraction. All right, so I got 6 pi over 4 for the 3 pi over 2. Then that makes this one 7 pi over 4. And then if I kept going back to where we started, I would get 8 pi over 4, which is the same thing as 2 pi, right? Okay, so that's the fourths. Well, the other thing we're interested in is the sixths and the thirds. So I'm going to draw another circle. And I'm going to put my quadrangles on it. So I've got 0 and 2 pi. We know pi is over here. We just learned that this is 3 pi over 2, and this one's pi over 2. And I'm going to take the top half of my circle, and I'm going to make 6 pizza slices. So I'm counting by 6, right? If the whole thing's 0 to pi, then every time I create a pizza slice dividing by 6, it's going to be pi over 6. So I'm going to hit there, 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 and there, right? Do you see that that creates 6 pizza slices? So then we're going to count around for those. So this one would be pi over 6. The next one would be 2 pi over 6, which we can reduce. That's going to be pi over 3. So I've got pi over 6, 2 pi over 6. Pi over 2 is the same thing as 3 pi over 6. Then we're going to have 4 pi over 6, which reduces to 2 pi over 3. All right, so I've got 1, 2, 3, 4. This one's going to be 5 pi over 6. Then 6 pi over 6 would be pi. And we're going to keep counting around and divide the second, or the bottom half of my circle into 6 slices as well. So we had 6 pi over 6. That makes this one 7 pi over 6. Then 8 pi over 6 is going to reduce to 4 pi over 3. All right, so that's 8. My 3 pi over 2 would be 9 pi over 6, which reduces 3 pi over 2. Then we're going to get 10 pi over 6, which is going to reduce to 5 pi over 3. And then we get 11 pi over 6. And if I kept going back to a full rotation, then we'd get 12 pi over 6, which is the same thing as 2 pi. Okay, so when we get into the unit circle, you're going to be labeling these angles on it. I want to see the reduced ones. I don't want you to write 4 pi over 6. You don't have to show me the 8 pi over 6. You'll just give me the reduced ones, or the simplified ones. All right, so let's get some angles here and draw them. All right, let's try seven pi over 4. Well, if we're going to do 7 pi over 4, I'm going to divide it up into fourths again. And so that's these angles. plus the quadrangles, right? And so I'm going to count around. That's 1, 2, 3, 4, 5, 6, 7. So my initial side, always on the x-axis. My terminal side, we just counted around to figure out where it went. And since it's a positive angle, I show a counterclockwise rotation. Let's try negative 5 pi over 6. So I'm going to draw my axes. And then we're going to be counting by the sixths. So let's just put the marks where those pizza slices go. And it's negative, so we're going to count in the clockwise direction. So we start at 0, and then I've got 1, 2, 3, 4, 5. So my initial side is on the x-axis. My terminal side is over here, and since it's negative, we indicate that we went in a clockwise direction. Can anybody tell me what that angle would be if we'd gone in a positive direction? One, 2, 3, 4, 5, 6, 7. It would look like 7 pi over 6, right? The only thing that tells me it's negative 5 pi over 6 is the arrow indicating the direction I went. And we're going to get to these in just a second. Negative 5 pi over 6 and 7 pi over 6 are actually called coterminal angles. They're angles that have the same initial side and same terminal side. All right, 14 pi over 3. Now we got the 3's from doing the 6's, right? So I can say this is an equivalent fraction to 28 pi over 6, and then I can use my sixths. All right, so what I'm going to do is put my sixths on here. And it's a positive angle, so we're going to go in the counterclockwise direction, and we're going to start counting around. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm still not there. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, still not there. 25, 26, 27, 28. All right, so there's my terminal side. Initial side is the x-axis. We went around the circle more than 2 times. When you draw your arrow to indicate the direction we traveled, it's also going to show the number of rotations. So we rotated once, then we rotated again, and then we finally got to our terminal side. What is this angle the same as if I didn't have all those rotations? It would be 1, 2, 3, 4 pi over 6, so 2 pi over 3, yes. If I only had the initial side and the terminal side, it would look like 2 pi over 3. All right, let's do a couple that are in degrees. Negative 240 means we're going to have a clockwise rotation. And to help me figure out where that's going to be, if I'm going negative, this would be negative 90. This would be negative 180. This would be negative 270. And this would be 0 or negative or positive 360. It's kind of up to me what I call it, depending on the rotation. Okay, those angles are only if I'm going in the negative direction. So 240 is in between 180 and 270, right? So we draw our initial side. And where is it between 180 and 270? Okay, I have to add 60 to 180 to get to 240. I would add 30 to 240 to get to 270. So it's closer to 270 than it is to 180, right? So these don't have to be perfect, but it's going to be about there. I want it to look like it's closer to 270 than it does to negative 180. And we need to show that it was a negative rotation. So negative 240, looking on where I drew that on my circle, and I didn't get it perfect. Any idea what that one is in radians if we were going positive? We just did it in the other example. Looks like 2 pi over 3, right? And in fact, if we did the calculation, it is. (405°). Okay, so we're positive. We're going to go a counterclockwise rotation. And 405° is more than 360, so it's going to be more than one full rotation, right? How much more is it than 360? Anybody do that in their head? It's 45°. Where does 45° go? Halfway between 0 and 90. So my initial side is the x-axis. My terminal side is at 45°, but my rotation is a full rotation and then going to 45°.